So good morning and welcome to PuppetConf. I enjoyed the keynotes and thankfully a lot of what I just heard, hopefully you guys will hear some resonance about the themes that you heard from Luke and Jim and Kate even in my talk this morning. Also, welcome to the first day of fall, I think. And I was just looking at that yesterday because 1 year ago, the work that I was doing, which kind of led to the theme of this talk, was right in the middle of its deepest kind of crisis. And I just remember that. It wasn't close to the release date of our project, which is more like November. It was right about now, right at the beginning of fall. So I'm going to talk about that a little bit with you, and hopefully it's a good story. It's something we can talk about, the emergence of cloud and getting business done on the cloud. A quick question, how many of you, just raise your hands if you're doing your business's workloads in a cloud computing environment? Okay, how many, and keep your hands up if you are working, if your work is in the operations of the cloud, like deploying the cloud environment. So most of you, okay. So caveat or reality check here, a lot of what I'm going to talk about is running business applications in what I call Userland on top of a cloud deployment. Puppet is great for a lot of deploying clouds. OpenStack especially is a big deal for HP, and there's a lot of work in operator space with cloud computing. My talk is going to focus on how a business deploys its applications on top of a cloud deployment and is as agile as it can be about that. So when I kind of put my thoughts together for this talk, I wanted to start with what's the most important, kind of the essence of it. And I really believe that the operators, the sysadmins that Luke was talking about, the grumpy heads down, trying to just keep that plane flying, our biggest value is when we enable our businesses to be agile. I like to use the phrase business agility. And when you keep your eye on that goal, then it helps put into context how you get there and the tools you choose, the what of your tool chain and choices like using Puppet and how you use Puppet. This isn't going to be just about cloud computing, using Puppet in cloud, or it's not going to be just about Puppet or Puppet Enterprise, which we happen to use in my business. It's going to be about how business results are delivered and made more agile, more iterative on top of those things. And so, bigger context is around business success on top of those tools and those technologies. I do think, though, when the emergence of cloud computing, especially in enterprise, mixes with the configuration management, the power of Puppet, and the way that our documentation, in essence, in ops now is an executable code, checked-in code for operations, that is yielding something that's in my business and enterprise space. It's a real pivot point for business agility, and we'll kind of get into that here. Quick high-level summary about what we're talking about. We're going to talk about cloud and Userland, what it means to be doing business on top of a cloud deployment or on top of something like Amazon public cloud, what it means to take your applications and make them agile in that cloud environment with the transformation. Infrastructure as code, what do I really mean by that? What has it meant to us and our success? How we're using Puppet, and finally just a theme about being agile with Puppet and with all those other life cycles that your business is enabling, your operations team is enabling for your business's success. I'm absolutely responsible to say thanks to members of the team. I'm just here as sort of the spokesperson for a great team up in Corvallis, Oregon, and some peers. Make sure recognition, this isn't all about me. Thank you, Eric. So who am I? I work at Hewlett-Packard. I'm in the printing business. I'm not in the cloud business. I'm not in the software business. I'm in the middle of inkjet heartland for HP. And it has made it an interesting journey to be working in this IT domain and involving with Puppet and doing all this cloud stuff. But foremost, I support a business that wants to make consumer printers really awesome and successful for the consumer market. We have web services which these printers plug into and enable user experiences that generally hundreds and hundreds of thousands of customers find to be compelling. Those services have to be hosted somewhere. So my work isn't physically inside these printers. HP understands it's a broader ecosystem, and folks like me, we've been working on the cloud side to enable the best features, the delivery of content into these HP's printers that differentiates them in the market. But just to kind of put things into context also, HP does a lot of stuff. Just in the printer space, we make gigantic printers too. I just like showing these pictures because sometimes people think, oh, HP's in printing. That bottom one there is about 100 feet long, and it's amazing what we can do in the printer world. Besides that, though. So more than a year ago, about June of last year, we were getting a lot of business done on Amazon, and we were using Amazon cloud computing in a pretty traditional IT fashion. This might be familiar to some of you guys, like, yeah, we're in the cloud, but it doesn't seem like it's any easier. Maybe it's a little faster to do some things, but it's not a whole lot easier than it was 10 years ago when I had racks of physical servers. Anyway, we were in that same sort of space. We had many hundreds of VMs infrastructure, a large mix of systems in prod and test and stage and dev, and along comes a mandate, oh, HP's spinning up a cloud business, you better stop using the competition. And you better do it right now. Drop everything and migrate. So the project in essence was, hey, move to HP Helion, which hadn't been labeled that yet, but move to HP's public cloud, you've got 5 months. And we weren't doing anything in any especially agile fashion, especially in operations. So what did that really mean? Well, first, let's talk about what does it mean to move that out of the way, to get serious about using the cloud. We were using Amazon as a button-click kind of web interface part of our platform. So when we had a project, we had to jump into this. Let's get serious about the cloud. So first order, I don't want to assert that cloud means public cloud, just like Amazon's current most popular model. Cloud can be any infrastructure that has APIs wrapped around it. Your on-premise traditional VMware stacks can be cloud-like if you're consuming it through its APIs. One of the questions I ask you folks is, if you're using the cloud, what percentage of your interaction with it is through APIs versus button clicks or in the web console? For us, we had a public cloud destination, but the most important factor was OpenStack APIs. We were going to be consuming the cloud as if it's software. Infrastructure as code is this theme you're going to hear me say more and more. And whether, again, it didn't matter whether it was hosted remotely. It could have just been in my local data center. If we have an OpenStack, HP Helion OpenStack deployment in my data center, I can consume that like software over the wire. And that was a core principle to how we approach this. So kind of deep theme here is the more you're going to hear me talk about it. Cloud isn't about where it is. It's about how you interact with it. And this is the foundation, I'll talk about it, the foundation of our work. Now, as I mentioned at the beginning, I live in Userland. There's a tremendous amount of work underneath Userland in the operations space, right? If you get involved with OpenStack and you're like, oh, we're going to stand up OpenStack. We're going to do the cloud in our data center. I've got a few servers. You've got a lot of stuff you need to learn, or a lot you need to appreciate that comes packaged by your cloud distribution. Nonetheless, there's just immense amount of detail underneath that. When you're talking about business and you want to run your applications and be as agile as you can with your apps, you either need to solve this or you need to focus on your strengths, running your applications, deploying and iterating them up on top of this. My expertise is not the depths of OpenStack. We had to focus on what we could own, which is above that. And we basically partnered with an internal vendor who knows how to deploy massive OpenStack and support that platform. We live here. Userland means you're focused on your applications. You're focused on the cloud as a robust underlying infrastructure, your platform upon which you use it through its APIs. You can be as fast as you can do anything in code. It's also benefit of Amazon. Any other real cloud is unrestricted by the kind of physical constraints. You're not worried about infrastructure and capacity. You're thinking about, what does my business need to deploy now? How do I want to scale that? How do I want to iterate that? So I focus on Userland. Underneath, people are worried about all those physical details. I like to think about routers as virtual black box routers. I like to think about storage as capacity and performance, not about spindles and physical proximity to systems. So let's talk about the applications we had then. So it was June again, and we had 3 big enterprise applications we needed to move. Our workload are these big Java apps that support different parts of our consumer printing ecosystem or our user experience. Part of it was a customer-facing user experience, subscriptions, a workflow engine which would render PDFs, and a vault of content that could be sent out to customers. Big stuff. Some of you guys I'm sure, are in enterprises that have those big monolithic workloads. Ours are named after Greek mythology, kind of classic IT stuff, right? Krakens and dragons, and we had to pick these up. And again, we were using Amazon to host some of these today, or at the time, and we looked at our deployment model, and it's all kind of 90s or early 2000s era playbooks, like install this way, written out, manually performed work. And if we're going to adopt the cloud and we're going to get serious about APIs, and we also need to get serious about deploying our applications like code also. And that led us to this conversation about Puppet. But at the time, we had this big footprint. I don't know if any of you guys have ever seen sort of a map of a bespoke portfolio, but everything is special, all snowflakes. We talk about pets versus cattle, lots of pet stacks, all of them slightly different. And there was no way we could pull off in 5 months moving this kind of infrastructure, 800 or so VMs from Amazon into HP's public cloud the same way. It's too much manual one-off work, and nothing would be reproducible. The quality would be just, it would not be agile. We'd not be giving our business any net benefit besides checking the box we made the migration. So we settled on some real serious principles, and this led to, again, like how we adopted Puppet, how we adopted infrastructure as code. These themes, this is the stuff I talk about when I have 30 seconds to say, what do you guys do? Well, we do infrastructure as code. What does that mean? Well, imagine all of your documentation is executable. Every step is checked in to version control. Everything is hyper consistent, and the 10th stack is identical to the first stack. Okay, well, those are like, great principles. It's easy to put on one slide, but what does it really look like? Well, it starts with the infrastructure and provisioning, that base layer. So in the cloud, those are the virtual machines, the storage, the network configurations, security groups, the foundation, kind of like your analog of the physical data center. Is the gear present? We need to make that, codified, and I'll get to the tech that we adopted for that. On top of that, then you have your systems, the state and the configuration of the systems. We adopted Puppet. That's why we're here. Puppet fleshes out that space so that your applications have a very consistent, reproducible, on-time infrastructure upon which to run. So the goal is then that your applications are there. Kind of philosophically, the city doesn't have. The city's skyline is beautiful, but it doesn't really have value unless the thriving businesses are in there, the engine is running of the city. The infrastructure is just static unless there's something happening on top of it. And again, we were always driven, being part of the business, not being sort of removed in the cloud side of HP, being part of the printing business, we were always motivated to focus on our applications and our customers. And so everything we did was driven by that need to kind of work from the bottom up to ensure everything can be customer delivery. Put it right in front of the customers consistently every time. So this is what it ended up looking like. We wrote code at the foundation level to work with OpenStack Heat. Within OpenStack, Heat is the orchestration provisioning engine that allows you to provision resources as code. And working with Heat, we then bootstrap into Puppet, separate domains, right? There's a bottom domain and there's this middle space. And I like to say, they interact with each other, but they're not the same. And this is just our pattern. For some of you, you might find that there are other ways to make this all one big step. But I like to look at our code base as our infrastructure provisioning code, that bottom layer, focus on, again, VMs, disks, storage, networking, and then Puppet running on top of that. We have a lot more code in the Puppet space. We have all of our application complexity, for instance, is inherent in the Puppet code, which is that meat which fleshes out the whole stack. But the point is, if you start at the bottom, you deploy infrastructure as code, you get Puppet involved, or configuration management, also driven by code, then at the end of that bootstrapping cycle, what you have is from nothing to running applications. In Amazon, it's basically the same thing. So this is the OpenStack model where you have heat. With Amazon, it's CloudFormation. We've demonstrated that because we've separated these parts of our tool chain, we swapped out OpenStack and heat for CloudFormation in particular business cases where we needed proximity in certain geographies or just Amazon-specific features. And everything else was the same. It allowed us to change cloud vendors without having to redo everything. So I mentioned at the beginning, right about this time a year ago, it was the hardest part of our project because we were not just migrating our workloads, but we were trying to rewrite the whole process. We were provisioning things no longer manually, no single button pushes, one button push, kind of stuff. And interesting learning that came from this. So our goal to go live, basically turn the light switch on for our production go live was supposed to be about November of last year on HP's cloud, and it was going to be sort of this moment of truth for our business team. Can we switch cloud vendors and make all these changes? And management was looking at things as, okay, November, it's going to be really intense, and like the week or two before our go live, there's a lot of attention on this, like kind of senior management visibility. All the ops people with ops DNA were definitely looking at the go live moment as that was going to be it. But for me, that was a really familiar pattern. Ops people do releases. Releases are a known amount of stress. There's certain interactions with stakeholders. There's a certain kind of things that go wrong, testing delays, familiar stress. What I found most interesting about this kind of adopting of a code-driven operations pattern is that for me, the biggest stress was about 6 weeks earlier when we were on the cusp of demonstrating end-to-end provisioning of our stacks. It was debugging Puppet code and debugging cloud provisioning orchestration about stacks of dozens of servers that have to come up in a certain way. It was when it was quiet and everybody thought we had lots of time that for me, suddenly I was basically learning what it feels like to be like a dev team manager, somebody who's working on features. And you have to hit functionally complete, X weeks before there's some golden bits and shipping it to the customer. We'd moved the operations burden back several weeks. We all knew once we could provision one stack, consistently, because we adopted all this infrastructure as code, we were going to be able to provision every stack the same way. That first one had to work, and our goal for that was 2 months in advance of the go live. So that, the takeaway is there's still going to be stress if you're adopting wholly new, codify everything, deep adoption of Puppet for your operations and your DevOps kind of model. But it's going to be, and it might be unfamiliar where that stress is, but it's really great to have that way up front. That moment where we could demonstrate, yep, we can consistently provision a prod-like deployment of our application in September. Even management was like, well, I guess that's good, but when do we get to see prod? It's like as of this moment, I can deploy you a prod stack whenever you want one. And now it's just about partner testing and other familiar patterns. So just fun part about using more of a dev mentality to operations. What does it look like now? So we do have push button deployment of our stacks. We have about 20 recipes. That's in the little drop down there. It's nothing sexy in our world. It's still just a Jenkins job, which triggers a bunch of orchestration code, the underlying heat deployment, all the cloud APIs get called. But it's a single button push. Right now it's our ops teams. We can add more recipes to this. We can open it up to other users as we kind of put a little bit more access control and some limits on it, because every stack turns into a set of cloud resources which have a cost. But it is push button. We went from 1,000 button clicks in the Amazon console to single button clicks after you fill in about 10 fields with some region and role-specific details. Our stacks aren't consistent. They're not identical to each other, but they are always consistent. This is just a snapshot of what our stuff looked like about 8 months ago. 3-tier applications, web tier, app tier, data tier, some NoSQL backend, some MySQL. There's a lot of variety, but the model, the approach we took allows us that we can have any number of these different types of stacks in our portfolio, and again, they'll always be consistently deployed because you define everything about them in code. So we're now up to about 16,000 OpenStack cloud resources in flight. That's 1,500 virtual machines and a whole bunch of networking parts and a whole bunch of disks, load balancers, databases, those sorts of things. Every single one of them defined by the underlying provisioning code. So let's talk about then how Puppet played the most into this. These slides are a little bit more reedy. Try not to kind of make you guys think about that. But the most important part about our current usage is PuppetDB. We've automated through Puppet, right? We provision all this cloud stuff. We have an orchestrator which goes into the Puppet master, or actually goes through the rake API of the console and auto-sign certificates, whitelists, the new VMs coming up. But kind of the day-to-day living with our portfolio and 1,500 VMs and our stack-based model is something I didn't mention earlier, but our primary focus now, we've up-leveled from VMs, like how many VMs do you have, is how many stacks of about 15 to 20 VMs in flight. We have about 100 stacks serving different business, test, or dev use cases. And because of use of Puppet and the way that we've used groups and classified the different VMs, we can then use PuppetDB to expose a dashboard, and there's a little graphic on the right there showing the relationships between different stacks in our portfolio. Puppet, again, it gives you that ability to not just control the configuration, but with facts and extracting higher level relationships in PuppetDB, we can always help the business see the relationships between which load test stack for this feature is connected to which load test stack for this and which partner. All that configuration richness is there, and then we can just expose it and draw cute little charts like that. Hira is a big part for us. I mentioned 2 parts here. YAML, we just started adopting that for basically credentials, things that you don't want to be able to transfer in over the wire in clear text. So provisioning of users' passwords into Windows servers, for instance, we use YAML. But the most awesome stuff that I enjoy how far our team has taken is what we call service directory. So we don't use standard YAML for our Hira. We've used Hira HTTP to connect to another web portal kind of app that we wrote, which lets our developers control the configurations of any parameterized values of systems that are using Puppet. So, Puppet is sort of like this ops thing. Sounds like audio. Oh, there's audio. Sorry? Somebody plugged their laptop into your Yeah, maybe. Hira is really awesome in a live, evolving dev world, right? Again, we have about 100 stacks. There's multiple, 6, 8 different dev teams we're working with. They each have dev stacks. They have test stacks. They have load test stacks. And the ops team kind of provisions these stacks and gives them to the developers. And then, of course, they need to do work with them. And instead of saying, okay, SSH into your box and just basically turn off Puppet and fiddle with stuff, you say, oh, we should be using Hira. Well, how do you use Hira if you're a dev team? In our world, we use Hira HTTP to give them a web portal where they log in, they are exposed to only the dev stacks for their application, not the prod stacks, and there's an auditable change log of the configurations they're making. They change key value pairs for their stacks, those propagate back through Hira to their stacks, and they get to interact with Puppet without having to work with the YAML directly or have to write any Puppet code. Biggest benefit for us and Puppet is the consistency, again, something I've been talking about them a lot. We do have some developers who like to touch the Puppet code themselves, so templates where their apps config files are changing, they want to add more values. Why not let them have some control over the Puppet, some of the Puppet files? Doesn't mean that they're managing the kind of the deeper structure that our DOPS team has adopted for module, core Apache modules or core pieces of our Puppet code base. But something we've learned is that giving the developers access is entirely reasonable. And yeah, orchestration, so another element of our stack, let's see if I have a diagram, I don't. mCollective, we're using that very successfully in a way that we didn't anticipate. There's some use cases people talk about with mCollective that are about sort of ad hoc queries and dealing with things in a kind of a triage way. We've adopted mCollective as part of rolling code. Our stacks have multiple app servers within a cluster, and sometimes one app server is special and needs to be rolled first or maybe last of when we're rolling the war files. So with mCollective, we've orchestrated control over Puppet. Again, and most people, when they use mCollective, it's around controlling Puppet runs. The same for us. But we found that plug that into a Jenkins flow, and it makes code deployment orchestration really effective, and allowed us to automate the continuous delivery of our applications onto the stacks that we provision. Other best practices I mentioned, basically goes to this point. We do use Puppet Enterprise, and I just want to kind of put a shout out to the Puppet Labs team for what value we got out of the Enterprise product. The most important part is the support we've gotten. It's not just that the support team is there, it's a well-integrated, tested package. It scales well. The installers made our lives a lot easier, and it's basically let our ops team focus on adding value with the developers and focus on business innovation. I mentioned, R10K is an important kind of integration with our Git, so that again, we're thinking about our Puppet code as code, we're checking it in, and with Git branches mapped to the environments in Puppet, things are much more native in a software development lifecycle. Roles and profiles are huge. I've got that on another slide here in just a second. Most important thing about Puppet Enterprise is the support we've gotten has been tremendous. It's almost like, I don't know what the analogy is. The support team has enabled us to make some really hard choices early, which has allowed for more scale than we ever expected. We're up to about 20 different applications we support from the original 3, and tens of thousands more lines of Puppet code than we thought we'd have, and it's supportable. It's really good patterns that the Puppet Labs folks have shared with us and helped us march toward. So what do we have today? So besides just provisioning of our stacks through automation, a living and breathing stack isn't static. We can roll the code for them, and because of using Puppet in the middle and the different environments, we can do continuous delivery of our applications onto existent stacks. So we have a choice now. Do you want to provision a new stack with everything clean and just deploy the app at a certain version, or just use the same continuous delivery test stack and roll code to it? This is a little snapshot of one of our slides that tells the story about basically hierarchy-controlled variables which dictate which packages from which repo get deployed to the stacks. You set a variable that says a particular Dragon or Kraken stack is in the ref environment, reference kind of customer reference static environment. The appropriate package will appear there through being dictated by a Puppet. And finally, is talk about evolving and sort of different life cycles. So the diagram on the lower right might be familiar to some folks who've taken Puppet training and just the idea of the Puppet code life cycle. But something I've come to appreciate above that is how that kind of DevOps engineer Puppet coding life cycle works is it plugs into higher order life cycles. There's the life cycle of the applications themselves, right? Your dev team is working on bug fixes and they need to deploy that, that fix to a stack. Well, that kind of goes back to this Puppet enabled automated life cycle. There's the stacks themselves. We're talking about cloud computing. Things are cheap, but they're not free. And sometimes you need to bring up like a load test stack, a pretty fat thing that costs a lot per hour. It has a life cycle, which is enabled, again, to be much more efficient because of automating your infrastructure provisioning and all of the automation that comes from the Puppet code. we now destroy cloud resources much more aggressively than we ever did. It's a modern kind of dynamic pattern. I think Luke mentioned that earlier during his keynote. Tools like Puppet and kind of cloud API-driven infrastructure allows for a lot more dynamic kind of platform, your infrastructure platform. Your data center is growing and shrinking in ever higher tempo, and it allows for, it's more cost-effective. Kind of most important, and kind of back to the original thing I mentioned, though, is the business has a life cycle, and especially if you're in a business that's trying to figure out what's the most, the best product, or just iterating, you're going to be changing code. You're going to be building up and tearing down stacks. You're going to be trying whole new applications, pilots, and then tearing them out and putting up new, kind of new resources to let the business go in the direction it needs to. That life cycle is one that ops is either kind of a hindrance to, or a necessary evil, or by adopting real cloud API-driven provisioning and tools like Puppet, the ops team or those DevOps folks are an active participant and an enabler of business agility. And it's nice how it scales from the very bottom. You're just thinking about checking in Puppet code all the way to iterating an entire business and allowing business decision makers to change course and that not be a major reset for ops. It's just stacks with a new flavor or a new code role. And, oh, yeah, I have just about 5 minutes for Q&A. So just a couple acknowledgements. I have some awesome pictures in here that I got off the web, but I asked for permission first, and he said yes. So Sebastian's great. And again, I'm just spokesperson for an awesome team of engineers that have made a lot happen inside the HP printing business. These guys get all the credit. Questions? Yeah. Oh, there's a mic. 1 second.
So my question is, whoa, loud. Jenkins as your as the self-service provisioning portal. Why?
Good enough for now. That's a question I've been asked by multiple managers. Right now, it is where the control logic is, and it was the fastest, most, it's just quick implementation, right? It allows the ops guys to get a ticket and say, oh, you need another stack, or you need 3 stacks. Click, run a job, click, and track it. We are hoping to build a portal which is a little bit more, presentable, that give to the developer community and the test community. But it's a placeholder, right? It's the kind of classic, I don't know if it's a DevOps theme, but good enough for now. Let's see, where's the mic? Yeah, way in the back first, I guess.
Can you hear me?
Yeah.
So we're doing something very similar. And I was curious, how are you handling, you mentioned if there's bug fixes that you need to apply, that it would go through that process. How are you handling tagging and managing that if your main trunk branch has already gone past, right? If you've already gone on to the next version and you need to patch back a version to production, how do you handle that with R10K?
So, first caveat, I'm not the best Puppet in-depth engineer on the team. I'm, again, spokesperson in some ways. But there's 2 elements to this, and it depends on whether the question is about our Puppet code needing to be patched or whether it's the application code. So for, I like the structure of this, but if we're talking about the business functionality, the WAR file that needs to be rolled, that's through the life cycle I already showed. But if there's underlying Puppet that needs to be managed, we do use tags or feature toggles, really, I think is what we are calling it. And we should talk offline. I'd probably get you a better answer than me mumbling through what I don't entirely grasp.
Okay.
Thanks. We had one over here. Oh, we have time.
Hi. So I'm kind of wondering, what was the level of cooperation between your ops and development teams, and was it hard to get the developers to buy into Puppet and this kind of model?
The developers haven't yet been forced to get involved in Puppet, but they have had to appreciate that their config files are going to look different. They quickly grasped Puppet parameterized embedded Ruby config files that are a necessity for us to glue things together. But generally, this started out as an exercise by those ops guys, which was allowed to be kind of a separate space. And we kind of came from a classic culture of that wall was a little too high between our two sides of the organization. Our ability to deliver against the requirements of the business faster has helped lower that wall, and the kind of evolution of the ops engineers into being coders, because we're writing Puppet code or writing Heat code, has also helped lower that wall so that there's ever greater conversation. It's not a pure DevOps thing. Our organization isn't the case study in beauty of DevOps, but by talking about code every day, that wall gets lower, and the developers are thinking, well, I can learn one other language. Why? It's not that different. And we have some good early adopter dev teams that are asking more and more about getting deeper into the Puppet code. So it seems like it's taking care of itself without us having to hammer through any cultural change. Any other questions? Okay. Thank you, everybody.